Okay, we're at Isle La Motte, Vermont, and we're sitting and touching a Chazy Reef, which is 460 million years old. It's one of the oldest reefs. And what's amazing is the fossil diversity. So we're seeing the early evolution of reef-forming organisms that started with bryozoan. They got a little more complex. They grow to include stromatoporids, sponges, chambered organisms, ultimately into coral, which are here. And we see many gastropods and many cephalopods. Right here, but below us is a mound. It looks like it's part of a stromatopod, these mounded domal features.
Let's go over. We found a nice one over here, right?
We have a nice gastropod right here.
Yeah.
This is stop number 1 at the Isle La Motte Fossil Trail. It's actually quite nice. There are 7 stops, and there is a visitor center that opens at noon on Fridays, Saturdays, and Sundays. So we happen to be here on a Friday by design. The importance of these outcrops are that they form a long ridge, hundreds of miles, north-south, that were a reef chain of organisms that when Iapetus, which is the father of Atlantis, it was the ocean before the Atlantic Ocean. So into the Iapetus Ocean, these organisms formed 460 million years ago. And at that time, there was a gentle bulge, linear bulge, that created these line of reefs. And these just happen to be extremely well preserved here on Isle La Motte, especially since the Preservation Society has ensured that. And the amazing thing about these reefs is that they tell a time of tropical conditions. So the paleo reconstructions of this area that's now in Vermont at 45 degrees north latitude was down at the equator when the Iapetus Ocean and these organisms were forming. So it's a really incredible series of outcrops, and the trail is excellently marked with lots of good information on the panels.
So this is a fossil cephalopod at the Isle La Motte. So this is the Chazy Reef, Ordovician in age. Here's some more bryozoans. Here we can see some cracks oriented along tectonic fractures.
Over here is more. And there's a succession, like as you go, so that's the south, we're going to the north. As you go north, you're supposed to get higher energy. So the cephalopod
but it's a little bit of a fresher surface. Here's some good fabric on the algal head. And then we're going to turn here, and then there is a gastropod right here. Let me see if I can zoom in a little bit. Here's the edge of the gastropod right there.
So we're at the Chazy Reef at the Isle La Motte Preserve, and we're at Stop 6. And Stop 6 is one of the most spectacular. Look behind us. It covers a very large area. And this is probably the greatest outcrop, the greatest extent outcrop we've seen here. And the key point here is the biodiversity. So this 460 million year old reef community is the first example of documented faunal succession. And what we mean by that is that when we look at the south of Isle La Motte, there are the limestones have bryozoan mostly, which are
I'll just stop here. Here's a nice guy.
you sit on the reef. So this is great. We're looking at stop 1 on the fossil reef trail, and we're touching a gastropod and a bunch of stromatoporids, and those are now extinct, but some incredible reef-forming organisms from 460 million years ago. This place is full of cephalopods, gastropods.
Oops, I couldn't finish. I'm not even taking.
Feel that cool breeze.
So here's the big Chazy Reef. Here you are. Charles is standing on one. So I guess it's subparallel here, like just at like the same angle of deposition.
I think we're looking at the bed. That's a very good one. See, the shell walls really stand out.
Here's a nice round stromatoprid.
Let me take a quick look and then I'll make...
Here's some nice fabric. So we're looking at some faults here, and they appear to be only 30, and I don't know if you can read my phone. Okay, so this compass says that we're going 12 north 10 degrees. We're 177 above sea level, and you can see the faults in the rock are going pretty much north south. Okay, so we're looking at north 30 degrees, and then as we rotate it north, and then north 30. Yeah.
Look at this, Linda.
Here's an algal head, and lots of modeling. Okay, so here's the back shell of a gastropod, and then his friend is a cephalopod.
More cephalopods. So we're exploring the faunal diversity. There's so many things to see, and we just found
What?
a sponge. Look at the, you can really see the fabric, and it's just chock full with all kinds of other shells and fossils. And
Is it a little more silicious where it's standing out?
yes, yes, exactly.
Here's a shell that's cut like this.
This is the thrombolite texture.
There's a little guy right there. Wow.
So bryozoan, you remember, they could be just the linear things. There's so many linear things here.
Charles, there's a three-dimensional view and I was getting a video, but then a voice appeared in the back. So this is kind of Hoyt limestone three-dimensional view type thing. Here we see kind of a cross section down in the crack. Now, this is a naturally occurring fracture, but allows us to see deeper into the outcrop. So here we see some silicification of the algal head, probably some kind of sponge mound. Maybe the sponges are more silicious.
So we're at stop 5, and what we're looking at here are algal heads and the stromatolites of the cyanobacteria. And you can see there's kind of a dome, and this was done by Max Pitcher in the 60s, who was doing geologic research, and looks like they took a plug. But the importance of cyanobacteria is that that's when we went from very simple organisms at 3.5 billion years old that were single-celled organisms to a proliferation of cyanobacteria that could produce oxygen. And so these organisms would build colonies, and then a storm or a wave would put sediment and possibly kill a lot of the little organisms, but a few would survive, and then they would build up another layer, and so they'd make layer and layer and layer, and part of their byproducts was oxygen. So around 2.5 billion years ago, there was enough cyanobacteria organisms such as these and the stromatolites that actually there became enough oxygen. It was called the Great Oxygen Event. And so some of the banded iron formations that we've seen at 2.7 billion years old, not enough oxygen in the atmosphere, but around 2.5 billion years, organisms like this produced enough oxygen. Now, these are not that old. These are 460 million years, but they're part of the faunal community here at La Motte Reef community, and this is Stop 5, a really dramatic example.
So we're here at the abandoned Fisk Quarry. It's a place where you can get dark colored limestone with cephalopods and gastropods embedded in it. And these are some float from the old quarry. And it's Ordovician in age. And then some people have left some little samples here. A particularly good sample is over here. Let's see, the little bryozoan white pieces. Some good modeling. Here you can see the Fisk Quarry in the background with the dark limestone. And there's an abandoned lake in there. So here we can see the edge of some of the quarry. Okay, here's a gastropod. Okay, so here's sort of a cross-sectional view of the limestone. Here's a gastropod, and a little bit of dark color here. It's wet, but here's the edge right up there, and then here's his little center. Okay, here's the sign for the Fisk Quarry.
So we've progressed about 1.5 miles to the south of the Isle La Motte Preserve, where we saw the good cell preservation and the high diversity of reef. Now we're a little bit farther south in slightly older rocks at the Fisk Quarry. The Fisk Quarry was a great location because it had these huge blocks of Chazy limestone, and it was right next to Lake Champlain. So the large blocks that have been removed out of this quarry operation could easily be transported on large boats and taken down to places like the Brooklyn Bridge and Rockefeller Center, where it was used for construction down the Hudson in New York City. And what's interesting as we go to the south along Isle La Motte is the diversity of the fauna is getting less and less as we go back in time. So this is slightly older than where we just were, and it's really hard to see close up, but there are a lot of fossils, but they're just not quite as diverse. And as we go, dominant here are stromatopods, and we have a frog chiming in. This is a wetlands area, and there's owls and all kinds of heron and lots of bird life and reptile life. But back to the rocks, as you go farther and farther south on Isle La Motte, from here you get older and even more simple reef forms. So you get the early bryozoans. So basically from the bottom up, the oldest reef-forming rocks are the simplest, and then they get more complex and more diverse as they get younger and younger. And so that's the increasing diversity upwards that is so significant about this outcrop, this 460 million year Ordovician limestone outcrop.